Hello everyone. In this video, I am going to start the subject digital electronics. This subject is also called as digital circuits. So, let me put the heading digital electronics, or this may also called as digital circuits. So, this digital electronics or a digital subject is common for electronics and communication students ECE, and it is also common for electrical students EEE, and this subject is common for EIE instrumentation students, and this subject is common for CSC computer science students. And it is this subject digital electronics is going to appear in various competitive examination. It will be useful for GATE, it will be useful for ESET and some other competitive examination. So now let me give you the basic introduction of this digital electronics and what are the syllabus or what are the modules that present in this digital electronics. Then we will start off one by one topic. So first, let me present you the syllabus, what we are going to study, syllabus of digital electronics or digital circuits. So let me present you the syllabus first. So in the syllabus, first module that we are going to discuss here is basics. So firstly, I am going to discuss the basics. Under the basics, I am going to cover three topics. The first topic is number system and its conversions. And second topic is data representation. Third topic is binary codes. And the fourth module is some basics like binary addition, binary subtraction, binary multiplication and binary division. So all this will comes under basics. So let me write the basics. Under this I am going to cover what are various number systems present in the digital number system and what is at conversion. So let's see number systems and conversions. And the second module that I am going to cover here is data representation. So the second module is data representation. Okay, how to represent the data in digital, what are the various formats we have. And third module that I am going to cover is various binary coded formats. Okay, anyhow I am going to cover here in the number system conversion itself binary addition, subtraction, multiplication and division, these some basic fundamentals that I am going to cover in this basics only. So these three are the main portions that I am going to cover in the basics of digital electronics. Then after completion of this, we are going to come to the next topic, which is Boolean algebra. Okay, so in order to design a circuit, we need to reduce the hardware. To reduce the hardware, we have some tools like Karna map. Boolean algebra is the first tool we have. So let's study what is Boolean algebra, what are the properties of Boolean algebra and what are the various basics present in the Boolean algebra. Let us completely study here. Then after, we'll study logic system and logic gates. After completion of this logic gates, so let me elaborate you Karna's maps, K maps. Okay, so after completion of this K maps, so let me discuss with you like digital circuits are mainly classified into two types. The first type is combinational circuits and the second type we have is sequential circuits. So let us study about what is combinational circuits and what are the various types of circuits we have like off adder, full adder, off subtractor, full subtractor, multiplexer, encoder, decoder. Likewise, we have various circuits. So here, so let me write you the main important topic in digital electronics or digital circuits is, the first one is combinational circuits, okay, and second one is sequential circuits. So about these two things I am going to make lots of discussion, and after completion of this combinational circuits and sequential circuits, let me tell you three more different topics we have, which is semiconductor memories, like RAM, ROM, etc. Okay, so let me elaborate you on semiconductor memories. After completion of semiconductor memories, so digital logic families. So after this digital logic families, let's finally study analog to digital, A to D and D to A converters, ADC, DAC, analog to digital converters and digital to analog converters. So these all modules that we are going to study in the subject of digital circuits or digital electronics. So I clearly told this subject is common for ECE, this subject is common for EEE, and this subject is common for EIE, and this subject is common for CSE. For these four branches, this subject is going to very useful. Okay, now let's start our discussion on basics. Okay, under the basics, the first module that I am going to cover is what is number system and how to convert one number system into another number system. So let's begin our first module. So generally number systems are used to represent the information. So number systems are used to represent the information. The most commonly used number system in digital are binary number system, nibble number system, octal number system, decimal number system and hexadecimal number system. So let me write the various number systems whatever I told. So serial number 1, 2, 3, 4, 5. 5 number systems that I said right now. So what are those number systems? Name of the number systems. Let me write what is the name. So first one I told binary number system, and second one I told nibble number system, and third one I told octal number system, fourth one I said decimal number system, and next one I said hexadecimal number system. Alright, these all are the various number systems that we are going to use in the digital. Okay, then serial number, name of the number system is over. Then next I am going to write its radix. Radix is also called as base, which is generally denoted with R, base R. Okay, so the radix of binary number system is base 2. The radix for nibble number system is base 4. The radix for octal number system is base 8. The radix for decimal number system is base 10. The radix for hexadecimal number system is base 16. Okay, so these radix are base, is very important. Now what is the maximum symbol? So what is meant by maximum symbol? You can observe, if radix is R, the maximum symbol is R minus 1. That means in binary, what are the numbers we have? What are the numbers that we have? 0 and 1. So what is the maximum value? 1 is the maximum value. In nibble, let us suppose take nibble. What are the numbers we have? What are the numbers that we have? So the numbers that we have is 0, 1, 2, 3 in nibble. So 0, 1, 2, 3. what is the maximum number or maximum symbol? So the maximum symbol is 3, hence r minus 1. If 2 is the radix, 2 minus 1 is 1. 4 is the radix, 4 minus 1 is 3. In the same way, let me write for the next 3. Okay, so the next one is octal. 8 minus 1 is 7. That means we need to write here numbers 0 to 7. In the similar way, decimal is 9. Okay, that means 0 to 9. And the next hexadecimal is 16. 0 to 15 only. 15 is represented with F. Okay, now let me write binary coded format. Finally, let me write binary coded format. So what is meant by binary coded format? So how we are going to represent what are the various formats that we have? So how to represent this? So let me, if I say about nibble. So for nibble we have one binary coded format which is BCN, binary coded format for nibble. Okay, binary itself, it is formatted in binary, no need to write. Nibble we have BCN, binary coded format for nibble. That means we can able to write 2-1 code here. So I will tell you what is this 2-1 code and entire things. For octal we have BCO, binary coded format for octal. Okay, that means 4-2-1 code. The code is 4-2-1. The code is 2-1. Binary itself formatted in binary. Again, no need to write. We are writing binary coded format. The name itself says in binary how we are gonna represent the things. Next, decimal BCD, binary coded format, binary coded for decimal. Okay, 8421. Next, hexadecimal. Hexadecimal means maximum symbol is 15F. So BCH, binary code for hexadecimal. Here the code is also 8421. Then what is the difference between these two, sir? So the difference between these two is it is valid from 0 to 9 only, whereas BCH is valid from 0 to 15. This is the clear cut difference. Please note down this. So kindly note down this. So please note down this so that I am going to start the formats that whichever I said. So kindly note down this. Yeah, very nice. So now let's see what are the binary coded formats that I said, like BCN, binary coded for nibble, binary coded for octal, binary coded for decimal, binary coded for hexadecimal. So let us see these formats now. So first, BCN, binary coded for nibble. So the binary coded for nibble, I said the format is 2-1. The maximum symbol that we are gonna represent is 3, right? So 3 means you can observe here 0, 1, 2, 3. How to write 0? Both are 0. How to write 1? Where 1 is present? 1 is present at this place. Okay, here the place is 0. And where 2 is present? 2 is present here. This place is 0. Where how to get 3? 2 plus 1 is 3. Hence we need to write 2 digits as 1 and 1. So this is the code BCN, binary coded for nibble. And next one, I want to write BCO, binary coded for octal, code for octal. So I said the code is 4, 2, 1. The maximum symbol that I said here is 7. That means 0, 1, 2, 3, 4, 5, 6, 7. Then how to write 0? 0, 0, 0. How to write 1? 0, 0, 1. Wherever 1 is there, just you have to keep 1. How to get 2? So at place of 2 you have to keep 1, remaining places are zeros. How to get 3? 2 plus 1 is 3. Whatever the digits we are using, then you have to replace it as 1. Remaining is 0. How to get 4? 4 means here it is 1. Remaining 2 are zeros. How to get 5? 4 plus 1. I am using these 2 places. Hence I kept 1s there. How to get 6? 4 plus 2 is 6. How to get 7? 4 plus 2 plus 1 is 7. So 1, 1, 1. So in this way we are going to get BCO code. The same way, next I want code for BCD. Just now I said that BCD code is 8421. BCH code is also 8421, but the difference is very clear cut. BCD validates from 0 to 9 only, whereas BCH validates from 0 to 15. So let me write 0 to 9 only here. 0, 1, 2, 3, 4, 5, 6, 7, 8 and finally 9. So let me fill this. How to fill this? Let's check here. 8421. Let me write here clearly so that I can able to understand to which digit I have to fill. So 0 means all are zeros. I am not using any digit. 1 means I am using this 1. Wherever I am using, at that place I will put 1. 2 means 2 is appearing directly. Remaining digits are zeros. 3 means 2 plus 1, 3. So I am using these 2 digits. 4 is appearing directly, right? So 0, 1, 0, 0. 5 means 4 plus 1 is 5. That means 0, 1, 0, 1. 6 means 4 plus 2 is 6. 0, 1, 1, 0. 7 means 4 plus 2 plus 1, which is 7. 0, 1, 1, 1. Then 8 means 8 is appearing directly. 9. 8 plus 1, 9. 1, 0, 0, 1. Okay. So this is BCD code, binary coded for decimal. In the similar way, I need code for BCH. Okay, please kindly note down this. Note down this or else take the screenshot. So note down or else take the screenshot. Okay. Next, coming to the next code, we see which is BCH. BCH stands for binary code for hexadecimal. Okay. Now how to write this code? Let us observe. 8421, which is valid up to 15. So I need to write 0 to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. But 10 is named as A, B, C, D, E and F. So 15 means F. Now I want to write codes for this here. Okay. So just wherever 1, if you want 1, write at that place 1. So 0 means all are zeros. So simply I am saying one logic here. Try to observe. 1 means write 1 0 1 1 1 0 1 1 1 0 1 1 1 0 1 1 1 0 1 1 1 digit 0 1 digit 1 1 digit 0 1 digit 1 1 digit 0 1 digit 1. Got it? Now 2 means 2 zeros 2 ones, 2 zeros 2 ones. Fill it. 2 zeros 2 ones, 2 zeros 2 ones, 2 zeros 2 ones, 2 zeros 2 ones. Okay. Next 4 means 4 zeros 4 ones. Okay. In the same manner you can fill 1 2 3 4 zeros 4 ones, 1 2 3 4 zeros 4 ones. Got it? And finally 8 means 8 zeros 8 ones. Very clear cut here. So 1 2 3 4 5 6 7 8 8 ones. Now you can cross verify. If you want 9, you can add 8 plus 1 is 9. If you want 12, you can add first two digits 8 plus 4, which is 12. Okay, in this way you are going to get these values. Note down this, all of you note down this. Note down this. So these are the binary coded formats that I discussed. Now let us discuss conversions. So I said about what is number system. So you can check the slides here. In first slide, what I given is syllabus. In this syllabus we are discussing the basics. So in the basics I started number systems today. So I given what are the various types of number systems in the second slide. What are the various types of number systems? Binary, nibble, octal, decimal and hexadecimal. Then how to get its radix and binary coded formats and what are the numbers. Then I focused on what is binary coded format, which are going to useful for us in order to have conversions. Hence I discussed about the various binary coded formats here. So after completing the binary coded formats, then now let us discuss number system conversions. So what are the various number system conversions we have? So one to another. Okay. So what are the various things we have? Let me write here. So first, decimal to any and any to decimal. Any means either it may be base 2, base 4, base 8 or base 16. Okay, decimal to any and any to decimal. Second conversion that I am going to discuss, here two are over, decimal to any is over, again any to decimal is also over. Second module I am going to discuss binary to octal and octal to binary. Again two methods are over. Let me have discussion about all this. First let me write what are the various models possible. And third discussion I'll make binary to hexadecimal and hexadecimal to binary is the third discussion that I will make. And the fourth discussion, which is final, that I'll make octal to hexadecimal and hexadecimal to octal. So these all are the various types of conversions that we have. Now let me give what are the fundamental rules how to convert one number system into another number system. So let me give the rules for this. After giving the rules, let us take some examples. So with the examples I am going to give you clear cut ideology how to solve any question in the examination paper. Okay. So first put heading decimal to any. So let me elaborate each and everything here. Decimal to any. So first all of you put heading decimal to any. Okay. Decimal means what? We know the radix is base 10. Any means what? Base 2 or base 4 or base 8 or base 16. This is the first model. And second model I will tell like any to decimal. Okay, here two things we are going to cover, not the single thing, two things. Okay, now you can observe any means what? Either base 2, base 4, base 8 other than decimal. Okay, because we are writing decimal here. Again don't take decimal, other than decimal. Any means other than decimal. Outside, other side what we are writing, decimal. So other than whatever outside we are writing. Okay. Now first let me write the rule. Rule for this is, let me write the rule. Rule for this is, so after rule let me take one example. With the example I will give clear cut idea how to solve the given question. So the rule here is divide the real part. So simply like doing LCM. Divide the real part with the radix. So what is the radix? If it is 2, do with 2 along with the radix. If it is 4, do along with the radix. If it is 8, do along with the radix. If it is 16, do along with the radix. So other than decimal. So fraction part. So what is real part? What is fraction part? I am going to tell you. For the fraction part, you should multiply along with the radix. These all operations will take place along with the radix. So I will give you clear cut example here after giving a rule for this. And for the second one, any two decimal rule is take the weights of radix. Weights of radix. Okay, take the weights of radix. So again, this part and this part. Okay, for example, if I write 23.47 like this, something, real part and fraction part. Two parts are there, right? So this side we will take positive weights, this side we will take negative weights. So what is positive weight, what is negative weight, everything I am going to explain you very clear cut with one example. Okay, just now observe the rules, try to remember these rules. Now let us take the examples here. Okay, let me take the example for the first module that I said, decimal to any. For this I am taking one example. So 248.2 base 10 to any means either base 2 or base 4 or base 8 or base 16. So let me explain you with the base 2 with this. So first read the rule. So first divide the parts. What are the parts? Real part. So what is real part? 248. Fraction part. So what is fraction part? 0.2. Okay, I divided real part, I divided fraction part. Then come to the rule. What is the rule? I said divide the real part along with the radix. So what is the real part? 248. So for this 248 I am dividing along with the radix. So I want to convert into base 2. Let us suppose now in this video I am saying the example for base 2. So I am dividing with the base 2. So 2 1 ja, 2 2 ja, 2 4 ja, 2 6, 2 2s, 2 3s, 2 1s, 2 15s, 1 is remainder, and 2 7s 1, 2 3s 6 1, 2 1s 1. Okay, so how many ones we got? 1 2 3 4 5. 1 2 3 4 5. Okay, so the answer should be right in this way. That means 1 1 1 1 1. 5 ones. How many zeros? 1 2 3. 3 zeros. This is your real part answer, at which the real part answer you will get in your calculator also. Okay, there is an option called radix. In that you will get the answer. But fraction part is important. So 0.2 is the fraction part. So for fraction part, what we need to do is multiply. Just now I written the rule. Multiply the fraction part along with the radix. So what is the radix? I considered 2. Hence I am doing with 2. 0.2 into 2, which is 0.4. Now 0.4 into 2, which is 0.8, write this 0 outside. Then 0.8 into 2, which is 1.6, now write 1 outside. So if I write 1 outside, we left with 0.6, 1 is vanished, right? 0.6 into 2, which is 1.2, write this one outside. Until we repeat some value or based on the options, we have to do this process. We need to write the answer in this direction, which is 0, 0, 1, 1, base is 2. Okay, 0, 0, 1, 1, whose base is 2. Please note down this. Note down this, note down fast. So in this method, in this way, we need to complete this method. Note down fast, note down fast. Okay, I told you very clearly how to do this process. Very good. So the final answer we got is, this is our answer. So this is the conversion from decimal to any. So for example, now your homework, assignment work is the same question convert to 4, the same question convert to 8, the same question convert to 16. That means what are the changes here? The division previously we done with 2 because we are converting into 2. Now we are converting into 4. The division should happen with 4. The multiplication should happen with 4. If we are converting into 8, the division should happen with 8. The multiplication should happen in 8. Okay, with 8 we need to multiply. So if we are converting into 16, the division should happen with 16. The multiplication should happen with 16. So try to clearly observe the rule. So read the rule 1 to 2 times, then you can able to solve any kind of problems. Okay. So next we'll take one example for the next module, which is any to decimal. Any to decimal. So any means what? I said you base 2, base 4, base 8, base 16. Decimal means what? Base 10. So for this, let me give you one example. So base 2, let me write 1010.10, base 2 to base 10. So I said very clearly, keep a dot. This side the weights are positive, this side the weights are negative. Then how to solve this? You can observe 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, positive weights. This side negative, 2 power minus 1, 2 power minus 2. You just multiply and add 1 into 2 cube plus 0 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0 plus 1 into, you can do separately also, you can club. That's not a problem, both you will get the same answer. Anyway, 0 is multiplied with something, the answer is 0. I am cancelling the things. 2 cube means 8 plus 2 power 1 is 2. Okay, 8 plus 2 10. 2 power minus 1 is 0.5, right? 1 by 2 means 0.5. So 10.5 base 10 is the answer. Okay, if I ask, the next assignment is, if I ask you to do the things with base 4. So entire thing, 4 power 0, 4 power 1, 4 square, 4 cube, 4 power minus 1, 4 power minus 2. If I ask you to do with 8, 8 power 0, 8 power 1, 8 power 2, 8 power 3, 8 power minus 1, 8 power minus 2. Okay, this side are positive weight and that side are negative weights. In this direction, we need to complete the problem. If I ask you to do with 16, same with 16, we will complete this. Okay, I hope this model is also clear for all of you. Kindly note down this model. I am giving 10 seconds pause here. So kindly note down this model. All of you kindly note down this model. Very good, very good. Okay. Now let us discuss the next model, which is binary to octal and octal to binary. So let me tell you the next model, binary to octal and octal to binary. So first let me tell you the rule. After that let me give you one example and let's solve that example. So binary means what? Base 2. Octal means what? Base 8. Octal means base 8 to binary means base 2. So for these two things is rule is apply BCF 421. Apply binary coded format 421. How you need to apply? So let us take a dot for real part and fraction part. You have to move in this direction. Here you have to move in this direction. So what is this moving in this right side or left side? Let us observe with one example. So binary base 2 10110.10. I want to convert into base 8. I clearly told you that for the given problem 10110.10, so this side and this side we have to move. Okay, so how many digits, which code we have to apply? 421. 421 means 3 digits we need to consider. 3 digits means, so in this direction, okay, these are the 3. I made one box. So what is the lagging here? One thing is lagging, so in this direction we need to add. So here you need to add this 0. Okay, this is the direction, movement or direction that we need to add. And here we are moving in this direction. So whenever we are moving in this direction, we need to add 0 here. Okay, you need to know where to add 0. So whenever we are moving this side, we need to add 0 this side. Whenever we are moving this side, we need to add this side. So the answer is, this is 6 and this is 2 dot and this is what? 4. 26.4 base 8 is the answer. Got it? So this is the conversion from binary to octal. In the same way, octal to binary. So 57.32 base 8 to base 2. Just keep go on writing the BCF values. How to write 5? 101. How to write 7? 111. How to write 3? 011. How to write 2? 010. Base is how much? 2. So that's the reason I told you very clearly the codes, binary coded formats, whichever the things that I explained in the lecture. Please go through the binary coded formats, then you can able to answer this kind of questions in simple ways. Okay, right. Now next conversion we'll discuss. The next conversion, here we have binary to hexadecimal and what? Hexadecimal to binary. Okay, let me write the radix first. So what is the radix of binary? Base 2. Hexadecimal, base 16. Hexadecimal is base 16. Binary is base 2. So how to make conversions? Let us observe here how to make conversions. So first let me write the rule. Rule is common for both. So what is that rule? So let me erase here. So what is this rule? Apply binary coded format. So which binary coded format? 8421. Previously we taken 3 digit. Now we need to take 4 digits. That's it. The same momentum right side, left side for real part and fraction part. So by following this rule, we can able to solve any kind of problem here. So now let us observe one example. So binary to octal, 10110.01 base 2 to hexadecimal, sorry, base 16. So how to convert this? 10110.01. So I am moving this side and this side. Whenever I am moving this side, 4 digits. Again here it is only 1 digit. So to make it into 4 digits, how many zeros we need to add? We need to add 3 zeros. So I added these 3 zeros this side, and here only 2 digits. So I need to make it these 2 digits into 4 digits. I need to add 2 zeros. So now what are these values? 1. This value is how much? 6. Dot. This value is how much? 4. Base how much? 16. Okay. In this way we can able to answer this question. So in the similar way, if 16 number is given, how to write? So AC dot 2F 16 number is given. How to write into binary? Just write its codes, because here the rule is apply BCF 8421. So how to write the rule? A means 1010, C means 1100, 2 means 0010, F means all are ones. Base how much? Base is 2. Have you understood? Please note down this. Please note down this. Kindly note down this. Next we will discuss the last model. We will discuss the last model, which is octal to hexadecimal. And next one, hexadecimal to octal. How to convert this? How to have conversion? So let us observe here. Octal means base 8, hexa means base 16. So while we are converting 8 to 16, what we have to do is first convert to base 2, then to convert 16. When we are converting 16 to 8, go via base 2. So you know the rule. 8 to 2 means apply BCF 421 code, 3 digit. 2 to 16 means apply BCF 8421, 4 digit. Again 16 to 2 means 8421, 4 digit code. 2 to 8 means 3 digits, 421 code. Okay. In this way we can able to convert hexa to octal and octal to hexa. So let's have one example for this. With this the number systems are going to complete. Okay. Let's take one example, octal to hexa. Base 8 736.25 to 16. What I said? Step 1, convert into base 2. So base 2. Okay, base 2. How to convert into base 2? So I said 8 should be converted into 2, 2 should be converted into 16. So tell me how to convert into 2, base 2, 8 to 2, write codes 111, 3 for 011, 6 for 110, 2 for 010, 5 for 101. This is what? Base 2. Now base 2 should be converted into 16. 2 to 16 means 4 digits we have to collect. 4 digit, again lack of 3 zeros. 4 digits, again lack of 2 zeros. What is the value here? 1. So this value is 1, 2, 4, 8, 13. 13 means what? D. This value is 14. E. Dot. This value is 5. This value is 1, 2, 4. Base how much? Base 16. Okay. Now let's check the same thing. We will take 1DE.54. We'll try to convert into base 8. 1DE.54. So let's check here. 1DE.54. This is 16. Now I need to convert this into 8. How to convert this? So first 16 should be converted into 2. Okay, 1 means 0, 0, 0, 1. D means 13, right? 1, 1, 0, 1. 1, 2, 4, 8. E means 14, 1, 1, 1, 0. 5 means 0, 1, 0, 1. 4 means 0, 1, 0, 0. This is base 2. Then from this base 2 we need to convert 8. Base 8 means 3 digits. 3 digits. 3 digits. Anyway, this is 0. This side. And now this side. 3 digits. 3 digits. Anyway, we'll add 1 0. Here this is nothing. Okay. Now 7. Okay. 1, 2, 4. 3, 6.25 base 8. You can check here. 736.25. 736.25. Okay. In this way, we can have our octal to hexadecimal and hexadecimal to octal conversion. Okay. So in this video, I clearly explained you that what are various types of number systems and how to convert one number system into another number system. In the next coming series of video lectures, we are going to learn this subject in easier way and smarter way. I hope everyone attend the classes, watch my series of lectures. See you all in the next class. Thank you.